here we go. So chapter 8 is on polynomials. Okay, and the word polynomials, what is a polynomial? Here's an example of a polynomial right here. Y equals x to the third minus 5x squared plus 7x minus 15. It's something that has many terms, right? Many terms. So it's an equation with many terms. It doesn't have to be an equation, but equation, function, something like that with many terms. Okay, that is what a polynomial is. So since chapter 8 is all about polynomials, let's write that down, kind of an informal definition, my definition. I don't think you'll find that in a book, but something like that. Polynomials is an equation with many terms, or equation, maybe a function. It could be a function, maybe not a function. Why are people leaving? That's not good. An equation with many terms. So here's the first term, second term, third term. So this one happens to have 4 terms. It can have 5 terms. It can have 2 terms. It could have 1 term and be a monomial and still be considered polynomial, even though poly means many, right? So something with many terms. Okay, and you will be doing more of this in trig pre-calc. So we'll get a beginning dose today in, yeah, that's fine, Kyle. And so we'll be leaving today in, we'll learn this chapter, but then you'll also learn more next year in trig pre-calc. So the first section we're doing today, we're investigating polynomial functions and learn how to sketch their graphs without using a graphing calculator or Desmos, okay? You will also learn how to write equations from graphs. The next section, we will explore complex numbers introduced in a previous course. We learned about imaginary numbers like a plus bi. Well, we're gonna learn more about them because that was just an introduction that we did earlier this year and in math 2, I believe. It is either math 1 or math 2. And you can read the other stuff from there. Okay, gonna go on to the next part here. Next slide. So that is what chapter 8 is about. So today's lesson is kind of based off this roller coaster, right? You ever been on a roller coaster ride, guys? Do you like roller coasters? You can put in the chat. What's your favorite roller coaster? Been to Discovery Kingdom? That's the last one I've been to. Okay, great. People rejoining me, people having electronic issues. All right, so let's read about number 1 here. Keep getting messages in the chat. All right, good. Yeah. In previous courses and chapters, you learned how to graph many types of functions, including lines and parabolas. We know how to graph lines. We know how to graph parabolas. Today, we will be graphing more functions called polynomial functions, something like this, for example, y equals x to the 4th, x to the 3rd. You know how to graph an x to the 3rd, but you don't know how to graph an x to the 4th, an x to the 5th, an x to the 6th. So that's what this chapter is about, okay? Graphing higher order powers, higher order equations. And when I'm saying that, we need to talk degree. What is a degree? A degree. We might have learned this a little bit in Algebra 1 is, let's just put it, the highest power in the equation or function. I'll put equation / function. Okay, what is the degree? That's going to be important this chapter. The degree of a function or a polynomial is the highest power in the equation. So for example, let's write this down. Example, this guy right here. And this can be before number 1. Y equals x to the 4th minus 4x to the 3rd minus 3x squared plus 10x plus 8. What is the highest power? And we always put polynomials in descending order, right? In descending order, which means highest to lowest. We always put the highest power first, right? Because I could give you one where they're all mixed up. Like it could be like negative 4x cubed plus 10x minus 3x squared plus x to the 4th plus 8. Okay, x to the 4th. So equals y. This is the exact same equation as that, but it's not in descending order. It's not put in order. This is put in order. What's the highest power of our x's in this equation?
4.
Good, 4, right? So that is the degree. So we say the degree of this equation is 4. The degree is just a number, one singular number, and it's the highest exponent. So degree 4. Why are degrees important? If I tell you it's a degree 3, what power is that?
Third.
The third power. So degree 3 means it has an x to the third in it. And we know those are called, that family of functions is called, what kind of function do we call that? Those are cubics, right? And we know that a cubic equation looks something like this, kind of like a roller coaster like this, right? So a cubic kind of looks like this. So, and we know if it was degree 2, if it's a degree 2, what family of functions is that? If it's got an x squared, that means it's a quadratic, right? So it's going to be a parabola, it's a quadratic. So the degree tells us a lot about the function. It tells us like how many curves there are. Okay, and that's important when we get to pre-calc calculus, because you're going to deal with a lot of polynomials in pre-calc and calculus. So the degree is important because it tells us, hey, how many bumps there are and stuff like that. You'll get more into calculus and pre-calc, into that stuff. In pre-calc, you'll study that more, okay? So, so the degree is super important. The Mathematicland Carnival Company has decided to build a new roller coaster to use at this year's county fair. The new coaster will have a very special feature. Part of the ride will be underground. The designers will use polynomial functions to describe different pieces of the track. Part of the design is shown at the right. So it goes down, up, like that, okay? Your task is to guess a possible equation to represent the track and test it on your graphing calculator. To help get an idea of what to try, start by checking the graphs of the equations below. Think about how the graphs are the same and how they are different. So here's the first equation, y equals x times x minus 2. What is the degree of this equation? And let's just write it down, y equals x times x minus 2. What is the degree of this equation? Is it 1, 2, 3, 4? What is the degree? Guess, take a guess.
2.
Good. How did you know it was 2, Mateo?
I saw a 2 in there.
A 2? This 2?
I don't know.
Okay, it's not because of this 2. It's because of another 2. It's because of this 2. How many x's are there? Okay, the degree is how many x's are there in the equation. And then exponents count for more, right? So if I end up multiplying this, distributing this, which we do, we would get x squared minus 2x. So the degree is 2 because the highest power is x squared. So if you count the number of x's, including the exponents, this doesn't have any real exponents except 1, the degree will be 2. Okay, so what about this second one right here? Let's copy the second equation right here. What is the degree of this equation? Y equals x times x minus 2 squared. What is this degree?
4.
It is actually 3. But thank you for guessing. I appreciate that. Because you're going to get an x squared for this one, right? Like when you square this out, it's going to be x squared minus 4x plus 4 is what this is going to be when you square it out. But then you have this x out in front that you're going to multiply by. So when you multiply x times x squared, you're going to get x to the third, and then you'll get other stuff that is lower, plus or minus, plus whatever. You're going to get other stuff, but the highest power is going to be x to the third. So this is a degree 3 problem because when this counts as 2 x's and this counts as 1 x, so there are 3 x's in this problem. Okay, that degree is going to, the highest power is going to be degree 3. Okay, now let's look at this last one. Y equals x times x minus 2 times x minus 3. What is the degree of this problem, guys? Take a guess, please.
4.
Guess again. Somebody else guess
3.
again. Yes, it's 3.
3.
Okay, it wasn't just going up because there's only 1, 2, 3 x's, guys. When I multiply this one times this one, I'm going to get x squared. When I multiply that x squared times that times another x, you're only going to get 3 x's. So the degree is 3. Okay, that's really important, determining the degree. So that is something new you've learned because you've never learned how to do that, obviously. We struggled with that a little bit. So hopefully we'll get better with this. Let's go to the next problem. So that's basically number 1. So hopefully you wrote down 8.1 for that section right there. We're going to go on to 8.2. So here's 8.2. In this investigation, determine which information in the equation of the polynomial function can help you sketch the graph. We're going to learn how to sketch these without a calculator. Write a thorough description, including examples and justifications of the relationship between polynomial function and its graph. To accomplish this task, first divide up the function below so that each team member is responsible for 2 of 3 of them. I believe we're going to do the first 4, and then you guys are going to do the last 4 for for the finishing it up. Okay, so I'm going to do the first 4. You're going to do the last 4. So we're going to go on. This is on your resource page. So as a team, examine the first polynomial, p1 of x is equal to x minus 2. So this just means polynomial 1, and then there's p2, which is polynomial 2. p3 is polynomial 3. We have 8 of them for this problem, so that's all that p1 means. It's the first polynomial of x. It's like f of x, right? But the first one equals x minus 2 times x plus 5 squared. To which family of functions does this belong? How do you know? Based on its equation, sketch the shape of its graph. Now use your graphing calculator, label the x-intercepts. How are the x-intercepts related to the equation? Reading from left to right along the x-axis, describe the graph. Okay, so this should be on our paper. So hopefully I can go back and forth here. It's kind of hard for me to go back and forth. So I'm going to go to the paper and let's see, enlarge this a bit because it's really tiny on the screen. There's the enlarge button. Ah, voila. Ah, c'est bien. Okay. Sketch the graph of the following polynomials on the provided. So this is the first one, polynomial 1, right? I need to get my pen. And what degree is this, guys?
3.
You guys agree? I would, because
Yes.
good. He's right. Degree 3. Good. Yay. We're getting better at it. Okay, you get to try 3 more. So this is going to give you an x squared when you square this, right? And then there's another x. So when you multiply another x, it's going to give you x to the 3rd. There's going to be a lot of other stuff, but we just care about what's the highest power. So what do we call that if it's degree 3, guys?
Cubic. Cubed.
Okay, we know what a cubic looks like, right? Because I just showed you. Okay, if we were to sketch this, if we were to take our calculator and sketch this, or Desmos or whatever, this is kind of what it would look like. And I could go on Desmos, but I don't need Desmos because I got a degree in mathematics. So I'm going to put a point here at 2, 0, and then I'm put a point here at -5. So at -5 and +2, cubic. And oh, do you remember what this is called, guys? From, I don't know, chapter 3 or something like that. Why is this one a double root? Because it's squared, right? So if it's squared, it counts as a double root. Remember what happens on a double root? We did this in your when we did your parent graph toolkits. That was like chapter 2. Remember, it should bounce off this point. And when I solve this for x, I get x equals -5. It should bounce off that point. So that tells me this graph is going to look something like this. It's going to go up, bounce off, and go up, and go up, 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 up like that. That looks like a cubic, guys. Is that good? I don't know how far this is. This is just a sketch. This is not completely accurate, but I think it's pretty decent sketch. You know, Okay, if I want an exact sketch, then I'll go to Desmos or my graphing calculator. But right now, we just need a sketch, right? Sketch. Okay, and because this is a double root, because it was squared, it tells me that it's going to bounce off that point. It's not going to go through the point. If it wasn't a root, this is your single root here, x equals 2. How do I know? Because we do x minus 2 equals 0 and solve that. And I added 2, and I got x equals 2. That's how I knew it had to pass through here, and it had to touch here. Okay, if it's a double root, it's just going to touch there, and it's going to come off that point. If it's a single root, it's going to go through that point. And that is how I got that graph. Okay. All right. So I need to scroll down. So I have to erase this writing. And drink water. Okay. So clear all. Go down to the next problem. Number 2. Okay. So degree. Let's determine the degree. What is degree of this one? How many x's are there? You just have to count this one. There's 1, 2, 3 x's, right? X times x is x squared, and then that times the other one is going to be x cubed. So the degree is 3. So again, what family of functions is that?
Cubic.
Very good. It's a cubic. So it's going to look similar to the last function. Okay, but there's a 2 out in front. And is that 2 going to affect the graph? What is that 2 going to do?
It's a multiplier.
Good. So the multiplier is going to do what to the graph? Well, if you have your, you could put what, whatever numbers you want, -3, -2, -1, 0, 1, 2, 3. We want to put a lot of numbers in. We're not going to plug them in, but if I were to, isn't it going to multiply all these numbers by 2? Right? So these numbers are going to be twice as big as if there wasn't a 2 there. So that shouldn't that stretch our graph? Like stretch it up and down, right? But can we still determine the x-intercepts, guys? Yes, let's write this down. Yes, we can determine the x-intercepts, which we call the roots, are also called roots, okay, by setting the equation equal to 0. Right? If this equation is equal to 0, and this is in factored form, it's already factored for us, which is nice. One of the equations is not going to be. Okay? So this is in factored form. We have all the intercepts right here. We just need to set each factor equal to 0. X minus 2 equals 0. The next one, x plus 2 equals 0. The last one, x minus 3 equals 0, and solve them, and those are your x-intercepts. So add 2 to both sides, x equals 2. That's our first x-intercept. Subtract 2 from both sides here, x equals -2. That's our second intercept. Add 3 to both sides, x equals 3. That's our last intercept, and we should have 1, 2, 3 intercepts. We should have 3 roots. And here's another thing. Whatever the degree is, that's how many roots you're going to have. Okay, if it's that's important. If it's degree 3, you should have 3 roots or 3 x's. We got 1, 2, 3 solutions, right? Our solutions are our x-intercepts. So this is where the graph is going to cross the x-axis at. So it's going to cross at 2. So here's 2, right? It's going to cross right there. And then it's going to cross at -2, so over here. And it's going to cross at 3, which is right next to the 2. I wish this graph was bigger. This is really hard to do that since it's close together, but that's okay. Okay, no double roots. So I know it's going to go like this, right? So can I make my graph go like that? Can I go, yeah, pretty easily. It'd be nice if we could find the y-intercept too, right? Then we could get like a little bit more accurate, but I'm going to go up, down, up. There we go. There's a graph. There's a sketch. That's just a rough sketch, right? We'll learn later in the chapter how to get more accurate points. We could make a table and get a lot of accurate points, but that's a lot of work. Or type it into your graphing calculator and use the table function. If you can, there's a table button on your calculator that will show you the table if you just type in the equation, it'll give you the table. Okay.
Wait, how
Okay.
come the first problem didn't have 3 roots in it if it was a degree 3?
Because one of them was a double root. It did have 3 roots, but double roots only show up once on a graph.
Okay, thank you.
Go. Okay, so let's look at, let's see, scroll up here. Let's see if I need to make this bigger now. Okay, is this in factored form, you guys? This is not factored. So guess what we need to do, guys?
Factor.
Exactly. Factoring is very important. It's not something that you just learn and forget about. That's why we spent so much time on quadratics last year and this year, especially at the beginning of the year. So to factor this, excuse me, I would, you know, we're going to do something times something. We're going to break this down into its 2 factors. But before I can do that, this has too many x's in it. And let's put what degree this is too. What degree is this, guys? Should be easy because it's not in factor form.
4.
It's degree 4. Right, this is what we call standard form when it's written like this. It's not in factored form, it's in standard form. And this is the higher power. This is the highest power, so degree 4. So is this a cubic?
No.
No. This is gonna look a little different. Okay, cubic goes like this. What is I'm gonna call this a quartic. I don't know if that's the name of this. I'm giving it that name, okay? I don't think you'll ever see that. I've always called these quartics. They don't really have names above degree 3, I don't think. So I'm just gonna call it a quartic. Okay, but notice how they all have an x here. So what we need to do first is take out an x, factor out an x. So I wanna take out an x out of here, and out of here. If I take an x away from x to the 4th, that's gonna be x to the 3rd, right? I still have x to the 4th when I multiply these two. It's still there, right? Minus 21x. So I drop an x from here because it's out here. I'm going to multiply it because I want to factor out an x. Plus 20 because I want to drop that x because it's out here. When I multiply this times this. Why do I do that? Because now I can take this x out. Now I can factor it because you can't factor it if they all have x's. You have to get rid, this last number has to be a number, a constant by itself in order to factor it, okay? Kind of, for the most part. Okay, so let's factor this. X cubed, ooh, I thought it was gonna be x, I thought it was gonna be x squared. That is no bueno, because the way I was going to do it is I was going to do x times x, and the factors of 21 or 20 that add up to 21 are negative 20 and negative 21, and that is how I was going to get that. I wonder, I hope this isn't a typo because that's problematic because now this is only a cubic. I only have 1, 2, 3. I am, you know what, let me go to Desmos really quickly and see x to the 4th minus 21x plus 20x and see what we get here. Let's go to Desmos. Desmos graphic calculator. Let's type in y equals x to the 4th power. Was minus 21x, right? 21x plus 20. I'm doing this 20x. 21x squared, was it? Or x? No, it was 21x, huh? And it was 20. So let's zoom out. Ah, like a parabola looking. Okay. Yes, x to the 4th they do look like parabolas, but they're usually a little bit more squared off. This one does look like a parabola. So oh wait, there was an x at the end of ours, right? Gosh, I'm forgetting. Was it x squared or x? Okay, go back to the resource page. X squared and x. Okay, so let me go back to there. Oops. So let me put an x squared in there, see how that changes our graph. X squared, see, look, whoa, look how crazy that went. Just by putting an x squared there and an x. Okay, so if it had just been an x and an x, it would have looked like a parabola, but look what happened here. We got like a W. Basically, you get like a W, but it's an asymmetrical W. Okay, asymmetrical W. And where are my points? How do I factor this one? X to the third, okay. If I take out like an x, I get x to the third minus, for this one, we don't know how to factor this one yet. We will learn this chapter, but I can't teach it to you right now because it's pretty involved. Yeah, we're gonna have to learn the P over Q rational theorem, and I'm not gonna teach that, it's too early to teach that to you right now. So let me go back here and, okay, do a little sketch. Where's my pen? So we could do a more accurate sketch, but it was basically something like boom, 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 something like that. Like that's kind of bad. It was a lot squished, more squished. It was more like something like that, right? Okay, because there's an X out in front, I do know one of these is 0 actually, so it should go through here. I should have made it a little higher. Let me go up there. There we go. So I'm amending my graph. It has to go through 0 because when there's an X sitting out in front there, that's a 0. Is it going through 20 and 21? Let me go back to Desmos here. Get rid of my pen. 20 and 21. No, it doesn't go through 20 and 21 because that's not how we factor it. So it looks like, there we go. It goes through 1, 0. It goes through 4, 0. It goes through 0, 0. And it goes through -5, 0. Okay, go ahead and copy those down really quickly or put that on your graph before I go back to the next screen. So it goes through -5, 0, 0, 0, 1, 0, and 4, 0 in numerical order. Okay, I'm not going to show you how to do that right now. We will learn how to do that. And in pre-calculus, you'll learn how to find the bottom point and these other inflection points, but not this year. Okay, so we just want to do a rough sketch right now. Okay, so right now we have to use Desmos to get a rough sketch. Later on in the chapter, we'll learn how to find these zeros. But I think that's the point of this exercise right now is you don't know how to do this yet. And that's our goal by the end of the chapter is how to figure out how to do it. Okay, so no, let's not leave the page. Let's go back to this page. Okay, so we got our graph. Hopefully you did the better graph that was on Desmos, right? We good with that one? Okay, the last one I'm going to do with you is number 4 here, unless I see other ones I need to do. Let me switch, scrolling on and off. Okay, what is the degree of this one, guys? How many x's is this? How many x's is that? How many x's is that? How many x's? It's basically adding, right? How many x's is that? You guys still there? Or did everybody leave to use the bathroom or get a snack? What degree is this? Somebody give a message in chat or something. I know somebody's there.
Yo.
Yes, what degree is this problem?
Degree 5.
Yes, good. And somebody put in the chat too, yay. Because this one counts as an x squared, right? X squared. And then times, this is 1x times this 1x times that 1x. So there's 5 x's. If we add these together, that's x to the 5th. So this is an x to the 5th power, degree 5. It's not a cubic, right? It's not a quartic, which is a word I made up. It's not 4th power. It's a quintic. I don't know. There's, like I said, there's no names for these. That's why we call them degrees. So what does degree 5 look like? Okay, degree 3 looks like this, right? Degree 5 is very similar, but it's gonna have like more mountains in it. It's gonna have one more bump in it. So degree 3 goes like this. Degree 5, we're gonna add one more bump. So bump and another bump. If I throw a negative in front, it's gonna go the other way. It's gonna go boom, boom, like that. Okay, and the bumps can go higher and lower than this. They can go higher and lower, but the end behavior is going to be different. One's going to go positive, one's going to go negative. When you have odd powers, right, odd degrees, their end behavior, we call that end behavior, is opposite directions. Okay, so one's going to go up and one's going to go down, always. Even if you think about a linear equation, right? A linear equation, a y equals 3x plus 5 is degree 1, right? It has different end behavior. One half goes up and one half goes down. So since this is an odd degree, one's going to go down, one's going to go up, and it's going to look something like this. But we know, what are our zeros? What's this 0 going to be? X equals what? -3, the opposite of this. What's the opposite of x plus 1? -1. What's the opposite of x minus 1? +1. Opposite of x minus 5? +5. One of these is a double root. Which one's the double root?
-3.
Yeah, because it's squared, right? So since they're supposed to have 5 solutions, okay, this is what you were asking about earlier, Ari, right? And let's clarify for the rest of you. This is supposed to have 5 solutions because it's degree 5, but it only has 4. Why does it only have 4?
Because they're a double root.
Right, the double root counts twice. This counts as 2 solutions because it's squared, so it happens twice. But in your picture, it's only going to appear once. Okay, so if we graph this, -3 is right here. There's -3. -1 is right here. -1. +1 is a couple units over, and 5 is 2, 3, 4, 5 right there. Okay, so our graph has to go through those points. I know it's going to look something like this. So I'm just going to go ahead and start down here, go down here, go up here. Oh, double root, sorry. Let me take that back. Okay, I went too high on the 3. So I was like, that's not working. So go down here, 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 and here. That works better? Are they going in opposite directions? Are they pointing in opposite directions? Did we bounce off the double root? This one has to bounce off of it, right? It can't go through it. It has to like bounce off it, like barely touch it. It does go through it, but then it bounces off it. It goes through here, and through here. Okay, it's got to go through that root, through that point, and bounce off this point. Okay, so this is just a sketch. It's definitely not going to be 100% accurate, but if you put this in Desmos, you can check me if you want to. Put this in Desmos, just replace this with a y, you're going to get something like this. Okay, so that's the main point of today's lesson is, hey, what do these graphs look like and how do I get them? You're not going to know exactly how to get them yet until the end of the chapter, but right now we can do sketches, okay? And how many roots they have and how many degrees, what's the degrees and how to sketch it, okay? So that's the main point. Okay, I got to clear this out. So your job for the rest of the period is to do these ones, okay? Let's take a look at these. These 4 are for you guys. So I can put you in breakout rooms and you guys can work on them if you want to. Determine the degree, and yeah, I like this. Can you factor this one? Try to factor this one. I think this one's going to be factorable. Okay, you know what degree it is. This one's in factored form, so you should get a really good graph of this one. This one is not in factored form, and they've got like 5 terms, so you're not going to be able to factor this. I don't think. We could do factor by grouping, but that's not going to work because there's 5 terms, not 4. So this one you might need to use Desmos for, or you can come up with this is the only one that you should use Desmos or a graphing calculator for, but the other ones you should not. Okay, do you guys want to go into breakout rooms? I think I'll put you in breakout rooms to work on this for like 10-15 minutes, just so you can work together and discuss it. Okay, so and that's what you're going to turn in for today. So let's go to, we got lots of time. So breakout rooms, breakout, where are they? Pause.